Imagine a bank with a vault full of thousands of historical loan applications. For each of those past files, the bank knows exactly who paid off their debt and who defaulted. Now, a brand new applicant walks through the door. It is easy to look backward and see who succeeded in the past. The real challenge is translating those raw, historical facts into an automated system that can instantly and reliably predict the future behavior of the unseen applicants sitting across the desk. This diagram outlines how we solve that problem using predictive algorithms, specifically a category called classification. Instead of calculating a continuous numerical value, a classification model sorts data into predefined discrete categories, like approved or rejected. Decision tree algorithms like C4.5 or ID3 take the guesswork out of this evaluation. They operate as mathematical engines that analyze historical risk and generate rigid, actionable rules. Look at this table representing a simplified training dataset. It holds historical attributes for past applicants, utilizing columns like income, credit history, and employment. The algorithm scans these traits to learn structural patterns. But notice this final outcome column. This is our dependent variable, the known historical truth of whether the applicant defaulted or repaid. The other columns are our independent variables, the traits we use to predict that truth. Without a historical baseline of known truths, the algorithm has no targets to learn from. The training dataset provides the exact facts required to build a predictive model. This visual demonstrates how the algorithm mathematically builds its model. It evaluates all the training data to find the single most important predictive attribute. It separates it out to act as the root node, splitting the data downward into good and bad branches. A single trait rarely guarantees a specific outcome. The algorithm evaluates the remaining subsets of data to create secondary splits. Here, it adds an income node underneath the good credit branch to separate the data further. By tracing a complete path from the root down to a final leaf node, a physical split translates directly into a concrete logical rule. If credit is good and income is greater than $50,000, then classify as approved. Let's test this logic. Here is a new applicant named Sarah, showing her specific attributes of bad credit and an $80,000 income. Pause the video, look at her stats, and trace her path through the tree. The evaluation starts at the root. Because Sarah has bad credit, the model immediately routes her down the right branch, terminating at a discrete, rejected classification. Her high income never factors into the math. The model abstracted thousands of complex historical records into a fast, repeatable classification engine, capable of processing an unseen applicant instantly. This diagram shows where the decision tree operates inside a corporate enterprise. The tree is simply the mathematical engine, executing the data mining phase within the broader 7-step Knowledge Discovery in Databases, or KDD, process. Once the tree forms its rules, the system evaluates the output patterns. Using statistical metrics like accuracy and support, it filters out accidental correlations and ensures the logic provides genuine, repeatable business value. Let's summarize the mechanics on screen. Our goal is classification for discrete outputs. Our input is a historical training dataset. Our process relies on algorithms like C4.5 or ID3 to build the rules, and our output provides class predictions for incoming records. Data mining tools like decision trees extract verified logic directly from historical actions. This allows modern enterprises to scale consistent, data-driven decisions across millions of individual interactions in milliseconds.